Okay guys, in this video we're going to take a look at the use of inverse trig functions in these compound expressions here. So giving the exact value of each of the following, the tangent of our cosine of negative a half and kind of what that means. So putting this into perspective, let's recall that our trig functions, sine, cosine, and tangent, and their reciprocals, their purpose is to take an angle, an input that is an angle, and map it onto a ratio. So our angles go to ratios. It's possible that there are cases where we already have the ratio, and what we want to do is kind of work backwards towards the angle. And these are these instances where we're using our inverse trig functions, things like cosine inverse, sine inverse, and tangent inverse. And you'll notice in every possible instance here, when I write a cosine inverse or a tangent inverse, on the inside of those functions we see ratios. Okay, and so we're going to take a look at interpreting these inverse trig functions as what are they? Well, an inverse trig function really does represent an output that has an angle. Okay, so when you look at this number 9 here and I say let's go find the tangent of this cosine inverse of negative a half, I want us to be truthful here. I want to really be clear that this inner part here is an angle. It's just that we really don't have our angle sketched for us. But the fact is, if you did ask me to find the tangent of an angle, I know the tangent of an angle. The tangent of an angle is y over x. So what we're going to start with is just kind of talking about, well, what would this angle look like? And I think that the best thing we can do for ourselves is sketch it here. Now, I'm told in the first place that our angle is in quadrant 2. So let's go ahead and sketch an angle that does terminate in quadrant 2. So that would be something like this right here. Okay, so here's our angle, and we can select arbitrarily a point on the terminal side here, and there's our right triangle. But this was kind of saying, hey, go find the tangent of this angle that, when you take the cosine of this angle, you get negative a half. So knowing what we know about cosine, going back to our definition of our trig functions here, cosine is x over r. So for me to say that this is an angle that gives us a negative a half or a cosine is kind of like me saying that I know my x value must be the negative 1 here, and I know my r value must be 2. So we kind of have to do some digging here. We got to go solve for y, and this is just using some Pythagoras here. Negative 1 squared plus y squared equals 2 squared. This would give us y squared plus 1 equals a 4. That kind of implies that y equals plus or minus the square root of 3. And again, to be clear here, I'm looking at this sketch that we're making of our angle here. This is in the second quadrant, so our y value must be positive. So looking at it this way now, we kind of have our x, we have our y, we have our r, okay? I was just asking us to go find the tangent of an angle, and knowing that our tangent of any angle here is y over x, let's go ahead and evaluate for this here. We have all the values we need. We drew our angle here. Sorry, I'm just kind of trying to play catch up here. So our tangent value, our y over our x, would be root 3 over negative root 1. So positive root 3 over negative 1, which is negative root 3, and that's kind of all we're after here. We just wanted a tangent value. Hey, likewise, letter B here, I want you to go find cotangent. So knowing that tangents, y over x, right, our definition of cotangent is x over y, and I suppose that we can start by sketching this angle here. It says this angle is tan inverse of root 3. Now you notice this time I didn't write where this theta lies, and the reason why is because a big part of these inverse trig functions is knowing what quadrants or what their ranges are, what quadrants they kind of give angles back in. So as far as, sorry, we'll get these in red here. As far as our inverse trig functions go, if we have arcsine, arccosine, and we have arctangent, I want to remember that arcsine always gives back an angle between positive and negative 90, given a ratio. But arccosine always gives back an angle between 0 and 180. This is because we hit all of our positive sine ratios up here in quadrant 1, and all of our negative sine ratios down here in quadrant 4. But with cosine, we hit all of our positive cosine ratios in quadrant 1, but we also hit positive cosine ratios in quadrant 4. So we just kind of say we'll hit all of our positive cosine ratios in quadrant 1, all of our negative cosine ratios in quadrant 2. And then arctan. Arctan is also fairly in the habit of giving us back an angle between positive and negative 90 here. So when I look at this time and I say, hey, tan inverse of root 3 and this root 3 is positive, I know that arctan always gives me back an angle in the first or the fourth quadrant. If arctan gave us a positive ratio, we must be in the first quadrant. So that means that when we sketch this time, we can imply that, hey, tan inverse of a positive, that must have been in quadrant 1 here. So let's go ahead and sketch our angle here. This is our theta. We'll pick a point on the terminal side, and we'll drop in what we know about this. We know the tangent of this angle is root 3 or root 3 over 1. So if tangent, which is y over x, is root 3 over 1, then we know our y value is root 3. Okay. and we know our x value is 1, we just have to go solve for r. And in this case, we get r squared. Let's try that again here. R squared equals 1 squared plus root 3 squared. So in other words, r squared equals 1 plus 3, and if that's equal to 4, then we get r equals only positive 2. We'll go put this on our picture. So last but not least, hey guys, what we're going to do is we're just going to go find the cotangent of this angle, and by definition, cotangent is x over y. Let's go ahead and write it here. The cotangent of this angle that we sketch would be x over y, or in other words, 1 over root 3, 1 over root 3. Or if we simplify that, rationalize it, root 3 over 3. Okay. So anytime we have these traditional trig functions on the outside and I give these inverse trig functions, the method would be to go and sketch that angle in the proper quadrant, and then you'll know x, y, and r. You can go ahead and evaluate for your outer trig function. Now letter C, in this case here, we notice that we have an inverse trig function on the outside. This is an angle we're looking for. And just to be very, very clear, with arc sine or sine inverse, you can only ever give me back angles between positive 90 degrees and negative 90 degrees. So the idea here would be that I hope you notice that we have a sine inverse of a sine. Traditionally, these things tend to just cancel, and we get left with the argument on the inside. But in this case, I can't tell you that it equals exactly 7 pi 6 because sine inverse never gives back angles greater than 90 or less than negative 90. And 7 pi 6 is like 210 degrees. So the way this works and the way we looked at this in class is, don't forget, let's go ahead and start just by evaluating this inner ratio. What is the sine of 7 pi 6? So, you know, kind of like we've looked at with our unit circle before, where does 7 pi 6 terminate? Well, 6 pi 6 plus another pi 6 would be 7 pi 6. And that would mean that we have a reference angle of pi 6. It also terminates in the third quadrant, okay? So that means that if we're finding sine in the third quadrant, it must be negative. So this is the same as the negative sine of its reference angle, pi 6. And the sine of pi 6, the sine of 30, we can go look at our unit circle sketch here. At a 30, our sine value is a half. So all of this work just to be able to say that this sine of 7 pi 6 is really the same thing as negative a half. And the reason why this is meaningful is because now we can go back and rewrite this as the sine inverse, okay, of negative a half. And really now I'm asking, what angle between positive 90 and negative 90 would give us a sine value that's negative a half? It'd still be 30 degrees. It's just that it would have to be a negative 30 degrees right here. And you'll notice that negative 30 degrees or negative, I should just say or, negative pi 6, okay? That is not the same as what you see here, and the reason why is because we have to work inside out. We can only spit out angles within an appropriate range for our inverse trig functions. So be careful. Cheers.